Okay, so we are going to solve quadratics by graphing. So when you're solving a quadratic, you want to choose the way that you're going to do it. So the first way we are going to solve is by graphing. And we already know how to graph a quadratic, right? We have our steps of graphing quadratics, so let's review our steps. So again, the first is to find the axis of symmetry, which is negative b over 2a. When you find your axis of symmetry, negative b over 2a, you draw your dotted line. After you find your axis of symmetry, you find your vertex, which is substitute the axis of symmetry into the problem. And once you substitute that axis of symmetry, that value of negative b over 2a, into the problem, you get an ordered pair, which is your vertex, maximum or minimum, the point where it turns. If there is an intercept, if it's graphable, right, the y-intercept, which is the c value, which is the constant, if that exists on your graph, then we go with that, and it is really easy. Sometimes, however, that value is too big, right? It's negative 20 or positive 50. We don't want to graph that because we're going to run into an issue with it, right? It's too big for our graph. So if that y-intercept sometimes does not work, we substitute 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 one space from the axis of symmetry, right? If our axis of symmetry was negative 2, you pick negative 1 or negative 3 to substitute, and that gives you an ordered pair. The fifth part may be, step 5, may be one that you can skip, right? If you have your axis of symmetry, then you have your vertex and your y-intercept and one space from the axis of symmetry. If you have all 4 of those, then you're good. If you have to skip step 3 because your y-intercept is too big or too small to graph, you substitute 2 spaces from the axis of symmetry. You can do that. Life is good. We continue on. We've got our 3 ordered pairs, so now we reflect and connect. So graphing doesn't change, right? I mean, we're solving it. We're actually going to get an answer now. We're taking it one step further. So we've graphed up until this point. Now we're going to solve it. We're going to get an answer. And the answer, right, what we're looking for, this solving by quadratics, the answer is the x-intercept, right? The x-intercept of our graph. So the answer is where it intersects the x-axis. Remember, when you have an x-intercept or an answer, or your, we call these zeros, you can have 2, you can have 1, or you can have none. So there are either going to be 2 answers to your problem. So you'll say x equals 4 and 6. You'll have 1 saying x equals negative 8. Or you'll have none. It doesn't intersect the x-axis. There are no zeros. And you'd say that there's no solution. Another really important part about this that sometimes we get a little confused with it, in order to solve, You can graph it when it looks anyway, right? To graph it, it needs to be in quadratic form, having an x squared and an a value. To solve it, we simply replace the y equals with 0 equals. So, and that's really the only difference in the way that these are written. Instead of in our previous problems where we've had quadratics, so if we look back at other pages in our notes, when it was graphing quadratics, it was just written y equals and then x squared plus 4, right? Or y equals and then, you know, the whole quadratic part. Now we're going to have 0 equals. So like transforming, right, there we're all y equals. Today, they're going to say 0 equals. It still is a quadratic. It's just not a generic quadratic. Because it has that 0 equals, we know that we're solving. The 0 equals tells us that we have to have an answer. So you have to take it one step further than just graphing it. So you should have a set of graphs, right? Fold on the dotted line. Then flip it back over. And this is going to get glued into your notebook. You may want to trim it a little bit so that it fits perfectly. This is a little bit too wide for this page. I'm going to glue it down in a minute. So I'm going to glue it when I'm done down at the very bottom, but I'm going to write on it while it's still loose so that it makes my life a little bit easier. I'm also going to cut just down to the fold so I have little flaps. And this first quadratic I'm going to put is 2x squared minus 2 equals 0. I know that it's a quadratic because I have an exponent of 2, I have an a value, right? But instead of it being y equals, it's going to be 0 equals or equals 0. So in here I'm going to rewrite that just so that I don't have to do a lot of flipping. And I'm going to graph it. So negative b over 2a. My b value doesn't exist, so it's negative 0 over 2 times, and my a is 2. Remember, we discovered that anytime your b value is 0, your axis of symmetry is automatically 0. So I go down here, and I graph it. I'm going to substitute this value of 0 in for x. 2 times 0 squared minus 2 equals 0, right? I don't really need that part because I'm solving for that value. 0 squared is 0 times 2 is 0 minus 2 is negative 2. So my vertex is 0, comma negative 2. Which is also, if you look up, my y-intercept, my c value, I already have it. Now I'm going to substitute one space from the axis of symmetry. My axis of symmetry is 0, so one space is the value 1 or negative 1. I'm choosing 1 because positive values are easier to substitute. 1 squared is 1 times 2 is 2. 2 minus 2 is 0, so I have 1 comma 0. Over 1, up 0. I'm going to substitute 2 values, right? I need 3 ordered pairs to reflect. So I'm going to substitute 2 spaces. So 2 spaces from the axis of symmetry. 1, 2 is the value 2, or could be the value negative 2. But again, positive values are a lot easier to substitute. 2 squared, 2 times 2 is 4. 4 times 2 is 8. 8 minus 2 is 6, so 2 comma 6. So I go over 2, and I go up 6. Step 6 is reflect and connect. So And that's graphing. We've already graphed. We already have this done. However, now I have a solution. I guess when we glue it in, let's glue it in up there because I need to write underneath here. So my solution, this has two x-intercepts. My first x-intercept is at -1. My second x-intercept is at +1. So this quadratic has two solutions because the solution to a quadratic equation is where it crosses the x-intercept. So after you graph it, I look at my x-intercept, -1 and +1. So that problem's done. Let's try another one. Let's do x squared minus 8x minus 16 equals 2x squared. Now this problem has an extra step in it, of course, right? It's not going to be as easy as this one. We have to get a little more complicated. So this problem does not say y equals, and it does not say 0 equals, but I can make it say 0 equals. If I remove or I take this 2x squared and subtract it, 2x squared minus 2x squared, I'm going to get 0. So if you subtract something from one side of a problem, you have to subtract it from the other side, right? Inverse operations. So I'm going to open this flap up and I'm going to do the math inside. So I'm going to put x squared minus 8x minus 16 equals 2x squared. And I'm going to subtract 2x squared from both sides. Remember, you guys, we've got combined like terms. We have to keep our x squareds together. I'm going to put a 1 in there just because life is easier when we have that. I have 1x squared minus 2x squared, which gives me negative 1x squared minus 8x minus 16 equals 0. Now I have it in 0 form. I have it in solvable form. So now I can graph this. If I'm using some of that prior knowledge from graphing, I know that this is going to open down because my a value is negative. I also know that I'm going to have an axis of symmetry that's not on the y-intercept. It's not at 0 because I have a b value. And I'm going to have to skip step 3 because my y-intercept is negative 16, and that's not on my graph. My graph only goes to negative 10. So here we go. I do negative b over 2a. So that is negative, and my b value is negative 8, over 2 times my a value is negative 1. Negative, negative cancels out to positive, so I have 8 divided by negative 2, making negative 4. So my axis of symmetry is at negative 4. I'm going to substitute negative 4 back into my problem right here. Negative 1 parentheses negative 4 squared minus 8 parentheses negative 4 minus 16. Remember, whenever you use negative values, you must use parentheses. So, here we go. I have negative 4 times negative 4 is positive 16, times negative 1 is negative 16. I have negative 8 times negative 4, which gets positive 32, and I have minus 16. Negative 16 plus 32 minus 16 actually equals 0. So my vertex is at negative 4, 0. Again, use a calculator, type it all in there. However, make sure that you're using parentheses. So negative 4, 0. My x-intercept is, or my axis of symmetry is negative 4, so I'm going to choose negative 3. To substitute. Unfortunately, I can't choose a positive value because I have an axis of symmetry of -4, so I have to get with a negative. Type it straight into your calculator or mental math. Remember though, parentheses around negative numbers. -3 times -3 is +9. So -9. -8 times -3 is +24. -16 gives me a ordered pair of -3, comma, -1. -3, -1. I'm going to substitute again, -1. This time I'm going 2 spaces over, so I'm going to substitute -2. Oops, that's a minus. -2, comma. -2 times -2 is +4, times -1 is -4. -8, -2, make -16, +16. -16 gives me, let's see, where am I? Sorry. 4, -4. So I have -2, -4. I'm going to reflect and connect. My answer, my solution, graphing is not enough. My solution is whatever it intersects at the x-axis, and it intersects right here. So my solution, this one has one solution. And it's x equals -4. That's the answer to this parabola. That's the answer to this quadratic. So really, again, it's graphing just with one extra step. So you have to be able to graph it, which we've practiced a lot of. And on top of being able to graph, you have to go back and find how many solutions you have and what those solutions are. I bet you can guess if this one was 2 solutions and this one was 1 solution, the next one is going to be 0 solutions. So this problem is going to say y equals x squared plus 6x plus 10. So this ordered pair, or this, not ordered pair, this quadratic, right, quadratic form, it says y equals. All of these have said 0, or we've made it say 0. I can take this one, and instead of that y value, I'm just going to put a 0. I can change equation form or function form. I can change it so that it's solvable. So I'm just going to make it say 0 equals x squared plus 6x plus 10. If I use some prior knowledge, I know that this is going to open up. I know that it's going to have an axis of symmetry that's not in the middle of the graph. And I have a step 3 that I can do, an intercept, that's on my graph. So I know that I can skip step 5. So negative b over 2a, -6 over 2 times 1. -6 divided by 2 is -3. So my axis of symmetry is at -3. Then I'm going to substitute that value back into the problem. -3 squared plus 6 times -3 plus 10. So my vertex is -3 comma, -3 times -3 is 9. 6 times -3 is -18. So 9 plus -18 is -9. Plus 10 is 1. So I'm going to go -3, 1. I'm going to choose -3, so I'm going to choose -2 to substitute. Oh, nope, just kidding. I forgot. I can do this. So my y-intercept is at 10. I can do that. I'm going to choose 1 over, which is -2. So -2 comma, -2 times -2 is 4. 6 times 2 is -12. So 4 -12 makes -8. Plus 10 is +2. So -2, +2. I'm going to reflect and connect. Oops, that was a terrible drawing. There we go. So this guy has no solution. Do not put x equals 0. If you put x equals 0 or the number 0, that means that 0 is a solution. I mean, the number 0 is a solution. You cannot say 0 for this. It must be no solution. No solution and 0 are incredibly different. 0 is a value. 0 could be an answer. If you put 0, that means there is one solution. You must put no solution. That's it.